What if the most terrifying alien world in the universe isn't in outer space, but hiding miles beneath our own oceans? Take a deep breath. We are going straight into the dark. Chapter 1. Look up at the night sky, and you'll see worlds we've spent centuries trying to understand. We've mapped the desolate craters of our moon, sent rovers to wander the dusty red plains of Mars, and stared deep into the turbulent hearts of distant galaxies. We constantly look up, searching for the unknown. But what if I told you that you don't need a billion-dollar rocket to visit an alien planet? What if the most mysterious, unexplored, and utterly bizarre frontier in the universe is right here, hidden beneath the crashing waves of our own world? Take a deep breath. Imagine the heavy, metallic thud of a thick titanium hatch locking into place above your head. With the spin of a heavy steel wheel, the bright, warm ocean breeze is gone. The sound of seagulls and crashing waves vanishes, replaced by the low, humming pulse of life support systems. You are now sealed inside a pressurized sphere, completely cut off from the Earth's atmosphere. Welcome to a different world. Today, we are taking a one-way trip down. We are going to answer the ultimate question: what if we could explore the deepest ocean floor? As our submersible slips beneath the surface, the turbulent white foam clears to reveal a vibrant, crystal-clear turquoise. Schools of silver fish dart playfully past our thick acrylic viewport. We are entering the epipelagic, or sunlight zone. This is the ocean you know, the top 200 meters. Here, sunlight easily pierces the water, driving the tireless engine of photosynthesis and supporting the vast majority of all marine life on Earth. It feels peaceful here, familiar, friendly. But this welcoming, sun-drenched environment is an illusion. It is merely a microscopic sliver of the ocean's true, terrifying volume. We are not staying here. We are going deeper. Watch as the bright turquoise water outside our window slowly shifts. As we sink, the color deepens to a rich blue, then to a heavy, shadowing navy, and finally to a bruised, oppressive indigo. The familiar schools of fish thin out, replaced by nothing but the vast, empty, silent water column. We have just passed 200 meters. We are crossing a threshold into the mesopelagic zone, the twilight zone. Notice how the world is changing around us. The light is fading fast, but it's not just getting darker. The water itself is physically stripping away the colors of the spectrum. You see, water acts as a massive filter, absorbing different wavelengths of light at different rates. Red light is the first to go, completely absorbed within the first a few dozen meters. If you were swimming outside the submersible right now and accidentally cut your hand, your blood wouldn't look red to your eyes. It would look like a dark, ink-like black. In this fading twilight realm, the color red is the ultimate camouflage. It is an invisibility cloak woven entirely from the physics of light. And then, the last hints of indigo fade into an absolute, suffocating blackness. You are now surrounded by a dark so pure, so absolute, that it feels heavy against the glass. Suddenly, a terrifying sound echoes through the small cabin, a sharp, groaning protest of metal under immense stress. Imagine that sound vibrating through your bones. That is the sound of the ocean trying to crush us. We are now passing 1,000 meters down. Welcome to the bathypelagic zone, the midnight zone. From this point on, there is absolutely zero sunlight. The temperature has plummeted to just a few degrees above freezing. But the real danger here isn't the biting cold, and it isn't the suffocating dark. It's the unforgiving physics of water. For every 10 meters we descend, the weight of the water above us adds another atmosphere of pressure. Right now, passing through the midnight zone, the water is pressing against every single square inch of our hull with the force of an elephant balancing on a postage stamp. If our titanium walls were to fail for even a fraction of a second, the implosion would be so violent and so unimaginably fast that our brains simply wouldn't have the milliseconds required to register that we had died. We would cease to exist before we even heard the glass break. We are completely isolated, suspended in a hostile, crushing void where human biology has absolutely no right to exist. We stare out into the pitch-black window, expecting to see a lifeless, empty desert. But slowly, almost imperceptibly, tiny, ghostly specks of white begin to float upward past the glass, like a reverse snowstorm. And then, a single pulsating blue light flashes in the distance. Then another, and another. We realize something incredible. We are not alone in the dark. Chapter 2. Those pulsing blue flashes in the absolute void outside our window aren't reflections. They are alive. You have just entered the largest glowing ecosystem on our planet. In a world where the sun has never existed, life has learned to create its own stars. We call it bioluminescence. Through a highly complex chemical reaction involving a light-emitting molecule called luciferin, these deep-sea residents produce a cold, ghostly glow. But make no mistake, this isn't an artistic display of beauty. It's a harsh language of survival spoken in the dark. Some creatures use it as a burglar alarm, flashing brightly to startle predators, or attract even bigger predators to eat their attackers. Others use it as a deadly, hypnotic lure. Imagine drifting in the blackness and seeing a solitary, glowing orb dancing gently in the water. Mesmerized, a small fish swims closer to investigate, only to find that the beautiful light is dangling from the head of an anglerfish, a monstrous creature with a mouth so massive and teeth so translucent and jagged, it looks like a nightmare sculpted from glass. Snap! The light goes out. The dark returns. As we continue our descent, the depth gauge spinning past 3,000, then 4,000 meters, the submarine gently shudders. We touch down. A soft, grey cloud of sediment billows up around the glass. We have reached the abyssal plain. This is the true ocean floor, a vast, undulating desert of mud and clay that covers more than half of the Earth's surface. It is the most expansive, yet most desolate landscape on our planet. Yet, as we ignite our massive exterior floodlights, pushing back a darkness that has reigned undisturbed for millions of years, we realize this desert is far from dead. Do you remember that snowstorm we saw falling past our window earlier? Scientists call it marine snow. It is a continuous, never-ending shower of organic debris falling from the sunlit world thousands of meters above us. It's made of flecks of dead algae, the decaying remains of animals, and microscopic particles of waste. It takes weeks, sometimes months, for a single decaying flake of this snow to fall from the surface down to where we are. It sounds grim, but this slow-motion rain of the dead is the fragile thread that feeds this entire dark world. Down here, absolutely nothing is wasted, and the creatures that scavenge this snow and the predators that hunt the scavengers have been warped by this extreme environment into things that defy common logic. Down here, the rules of biology are rewritten by the cold and the crushing pressure. Welcome to the realm of abyssal gigantism. Because food is so incredibly scarce, and the water hovers just above freezing, metabolisms slow down to a crawl. Animals live longer, grow slower, and somehow they grow massive. Out of the shadows of our floodlights steps a creature that looks like a common pill bug you might find under a rock in your garden. But this one is the size of a dog. It's a giant isopod, a heavily armored ancient scavenger patrolling the mud. And lurking even further in the gloom, Just beyond the reach of our lights, ghosts of the deep slowly drift by. Sleeper sharks that have been swimming these dark waters in slow motion for centuries. And perhaps, somewhere out there, the elusive colossal squid, a predator with eyes the size of dinner plates, armed with tentacles lined with razor-sharp, rotating hooks. We are sitting at the bottom of the world. The pressure is crushing, the cold is absolute, and the neighbors are terrifying. For a long time, humanity believed that this was it, the absolute end of the line, the flat, barren floor of the Earth. But as our submersible creeps forward over the mud, our sonar pings echo back with an alarming reading. The flat plain ahead of us suddenly drops off. The ocean floor is torn open. We haven't reached the bottom at all. We've just found the entrance to the underworld. Chapter 3. We steer our submersible over the jagged ledge, and the ground simply falls away. The headlights of our vessel reach out into an empty, terrifying void. We are no longer hovering over the ocean floor. We are descending into a colossal scar in the Earth's crust. We are entering the Hadal-Pelagic Zone, the realm of the deep trenches. Named after Hades, the Greek god of the underworld, this is a place where the ocean doesn't just sit on top of the rock, it is swallowed by it. We are plunging into the Mariana Trench. To understand the sheer scale of this abyss, imagine taking Mount Everest, the highest peak on our planet, and dropping it into this chasm. The peak of the mountain would still be submerged under more than 2 kilometers of water. This gargantuan canyon wasn't carved by water like the rivers on the surface. It was born from the violent, slow-motion collision of the Earth itself. We are diving into a subduction zone, a tectonic battleground where the massive Pacific plate is being dragged relentlessly beneath the Mariana plate, tearing open the crust and pulling the ocean down into the mantle. As we pass 6,000 meters, then 7,000, the pressure outside our tiny titanium bubble becomes almost incomprehensible. It is over 1,000 times the pressure at sea level. More than 15,000 pounds of force are pressing against every square inch of our ship. The water here is so compressed, so incredibly dense, that if a standard military submarine dared to dive this deep, it would be crumpled like an empty soda can in a matter of seconds. You would expect this place to be the ultimate dead zone, a freezing, silent grave at the absolute bottom of the world. But as we sink deeper into the narrow, V-shaped canyon, the temperature gauge on our dashboard suddenly spikes. The water, which has been hovering near freezing for miles, is rapidly getting warmer. And then, through the murky gloom, our lights reveal something that looks like it was ripped straight from a science fiction nightmare. Towering out of the sea floor are jagged, Gothic chimneys, some as tall as a 3-story building. And violently erupting from the tops of these rocky spires is thick, billowing black smoke. We have discovered a hydrothermal vent field. But that isn't actually smoke, it is water. Searing hot, highly acidic water violently spewing from cracks in the Earth's crust. Deep below us, seawater has seeped into the magma chambers of the Earth, becoming superheated and loaded with dissolved, toxic minerals before shooting back out into the freezing ocean. The water blasting out of those chimneys is over 400 degrees Celsius, hot enough to melt solid lead. So why isn't it boiling? Because the crushing, unimaginable pressure of the ocean above us physically prevents the water from turning into steam. It holds the liquid together by brute force. And right here, in the presence of searing heat, toxic chemicals and crushing pressure, we find the most astonishing twist in our journey. This hellish environment isn't a dead zone. It is a thriving, bustling oasis of life. Massive, tangled colonies of giant tube worms, some over 2 meters long, reach out into the black water with bright, blood-red plumes. Ghostly white crabs scurry blindly over the jagged rocks, while strange, translucent shrimp swarm in the violently hot water. But how? How does an entire ecosystem flourish in absolute darkness, completely cut off from the sun? The answer is chemosynthesis. Up on the surface, all life depends on plants and algae using sunlight to create food, photosynthesis. But the creatures down here don't need the sun. They don't care if the sun completely burns out tomorrow. The base of this food chain relies on alien-like bacteria that live inside the giant tube worms. These bacteria eat the highly toxic hydrogen sulfide gas spewing from the vents, using the Earth's internal heat and chemicals to produce pure energy. We are looking at an alien biosphere right here on Earth, an ecosystem completely divorced from the surface world. As we hover before these black smokers, watching life thrive in a place where it mathematically shouldn't exist, we are forced to ask one final, staggering question. If life can survive this, where else in the universe could it be hiding? Chapter 4. Leaving the chaotic, boiling energy of the hydrothermal vents behind, we drop into the final stretch. The canyon walls close in, and the water grows deathly still once more. We are now sinking toward the Challenger Deep, the absolute lowest point on the surface of the Earth. At nearly 11,000 meters, almost 7 miles down, the pressure here is so intense it is physically compressing the water, making it denser than the ocean at the surface. Finally, with a gentle, silent puff of pale dust against the glass, our submersible touches down. We have reached the bottom. Sit in this silence for a moment. Look out into the infinite black. Right now, there is more distance between us and the sunlit surface than the cruising altitude of a commercial airliner. It is a lonely, crushing, frozen wasteland. But as we rest at the very bottom of our world, staring out into the abyss, we realize that this journey hasn't just been an exploration of Earth, it has been a window into the cosmos. Remember the thriving, alien-like ecosystem we just left behind at the hydrothermal vents. The creatures surviving on toxic chemicals and internal planetary heat. That discovery didn't just rewrite biology textbooks, it completely shattered our understanding of where life can exist in the universe. For decades, astronomers believed that for a celestial body to harbour life, it had to sit in the Goldilocks zone, the perfect, safe distance from a star to maintain liquid water on its surface. But the deep ocean floor proves that the sun is completely optional. And this realization changes everything when we look out into our own solar system. Consider Europa, an icy moon of Jupiter, or Enceladus, a moon of Saturn. Their surfaces are barren, frozen wastelands of solid ice, constantly blasted by deadly space radiation. But beneath those miles of thick ice lie vast, global, liquid, saltwater oceans. The powerful gravity of their massive gas giant planets stretches and squeezes these little moons, generating immense internal friction and heat. Which means right now, in the absolute pitch-black depths of the alien oceans on Europa and Enceladus, there could be hydrothermal vents erupting from the core. The bizarre, chemosynthetic life we found hidden in the Mariana Trench might not just be a freak of Earth's nature. It might actually be the most common blueprint for life in the entire universe. By diving into our own darkness, we may have just discovered exactly how to find life among the stars. As our submersible releases its heavy steel ballast weights and begins the long, slow ascent back to the world of light and air, we are left with a humbling truth. Humanity has spent billions of dollars sending robotic probes to the very edge of the solar system, yet over 80% of our own ocean floor remains completely unmapped, unobserved, and unexplored. We literally know more about the craters on the Moon and the dusty valleys of Mars than we do about the bottom of our own seas. Who knows what else is down there, hiding in the dark? What ancient geological mysteries, what unimaginable and terrifying creatures or what groundbreaking biological miracles are waiting in the pitch black just miles beneath our feet. The next time you stand on a sandy beach and look out at the endless blue horizon, remember that the shimmering surface is just a roof. Beneath it lies a different world, vast, hostile, and teeming with secrets. The deep ocean is the final frontier on Earth, and we have only just begun to scratch the surface.